Okay, so we're continuing high degree polynomials, but what we're going to focus on today are the factors, the linear factors. Of these polynomials. Alright, so if I gave you this problem, 0 equals x squared minus 5x plus 6, and asked you to solve that, what would you do?
Factor it.
Okay, so we factor it. We want to make sure that we factor it properly. Alright, and now what?
So 5 x equals 3.
So 0 equals x minus 3 and 0 equals x minus 2, right? We would have both of those, and then x is 3 and x is 2. I guess I wrote mine backwards, but that's basically the concept there. What if I said the factors, or let's say this, let's say the answers for something like this were x equals 2 and x equals 5. Then what was the polynomial? Do you have any ideas how you could figure out what the polynomial was if these were the answers? Okay, so
Wait, you would get it over to x.
okay, so we have x minus 2 equals 0 and x minus 5 equals 0. So it would be x minus 2 times what?
Times x minus 5.
Okay, and then I would multiply that out and get x squared minus 7x plus 10. Does that make sense? How I worked that backwards? Now luckily, yesterday we had a lot of different things. Luckily today, there aren't as many things. Really, we have just talked about the two things that we need to know. The linear factors and the, if I have the answers. So those are going to be the two questions that we're going to deal with for today. So if I had, for example, f of x equals negative x cubed plus, well, let's do positive x cubed. We'll do an easy one. Yeah, let's do positive x cubed plus x squared. Let's do plus 6x let's do 8x. There, 8x like that. This is a plus right here. So let me write that more clearly. X cubed plus x squared plus 8x. And I say to you, find the roots. Well, what I'm going to have to do is I'm going to have to factor this, just like I did the quadratics, and then set to 0, and solve. So how could I factor that?
Take out an x.
Yes, that's going to be something you're going to have to be very careful of that you actually do. So I take out an x. Now, if possible, I would factor this one. Is that one going to be possible? No, that one's not factorable. So what do I use in this case when I have a quadratic that's not factorable? Quadratic formula. So I need to use x equals. Now I'm going to set this equal to 0, so that would be the next step, I suppose. So we're going to say, or for finding the roots, we're going to say 0 equals. And then we're going to go ahead and use quadratic on this piece. So x equals negative 1 plus or minus the square root of 1 minus 4 times a times c all over 2 times 1. Do you see that the thing inside of this radical is negative? Okay, so that means that this is going to result in complex roots. Our discriminant is negative, so this is going to be complex. And for now, towards the end of the chapter we'll actually use that, but for now we're going to not worry about that. So once we recognize that this is complex, we discard that. And then we'll say, well, we have this piece, x equals 0. So this is our only root. That's our answer. Now what is a root? A root, for now, is going to be where this crosses the x-axis. So we can use our calculator to help us if we would like. We graph it and gsolve, find the x-intercepts, or the roots. Now, we don't always have to factor. Maybe we're given it already factored, in which case we don't fight with it. We don't make it more complicated. We just accept the fact that we're given something easier to deal with. So let's say I have, same question, let's say I have f of x equals 2x plus 1 in parentheses, and then x minus 3, and then x plus 5. Why not just do one more? X minus 8. There. I have 4 of them. It's already factored. And thank goodness, because if it wasn't, this would be a degree 4. And I want you to see why it's degree 4. What's the power on this x? 1. What's the power on this x? What's the power on this x? What's the power on this x? Okay? And that makes this a degree 4. Well, why is that? If I were to multiply this all out, do you see that we'd end up multiplying at some point all these x's together? Do you believe me on that? And that would give me a power of 4? Because x times x, x times x times x times x, that's going to be x to the 4th. So this is a degree 4 because I have 4 of them. But anyways, not really what I wanted to do with that. If I want to find the roots, I'm going to say, well, this 2x plus 1, that's going to equal 0. This x minus 3, that's going to equal 0. X plus 5, that's going to equal 0. And the x minus 8, that's going to equal 0. And then I solve each one of those. X is 3, x is negative 5, and x is 8. And then I have to solve this one. X is also negative 1/2. And those, all of those would be my answers. So it's like what we did in the last chapter with the quadratics when we solve, except instead of just having 2 answers, we might have 4 or 5 of them. All right, we're going to find the zeros. Okay, but before I get to that, I'm going to ask us, well, what's the degree of this? What's the degree? Do you see, look up so you see what I'm talking about. Do you see that when I squared this, somewhere when I actually square this, I'd get an x squared? And when I cube this, somewhere I would actually get an x cubed. And then when I multiply those, I would have an x squared times an x cubed somewhere. And what would I get? X to the 5th. So that means the degree of this is x to the 5th. So it's 5. The degree is 5. Do you see where I got that? Okay, so we're finding the zeros. So that means x minus 3 is going to equal what?
0.
0. And x plus 5 is going to equal 0. So I get x equals 3, and then x equals negative 5. But there's one more thing I need to account for, so that's this squared, and that's this 3. Now, it actually doesn't change the answer any. It just means this root happens twice. So I'll say multiplicity 2. Because it's squared. And this one right here, I'll say multiplicity, what do you think? 3. because it's cubed. It happens 3 times. Do you need any more examples of finding the roots from the polynomial when it's already factored? No? We're good? All right. All right. We need to understand the terminology. So we need to understand what standard form is versus factored form. Okay, so these are 2 different things. They are both going to represent polynomials. Now, when we did standard form from the last chapter, we had something like this, right? Remember? Okay, that's the same setup as for these. So let's do a factored form. A factored form. Let's start with y equals x plus 4 squared times x minus 3. Okay, this is a factored form. Now, don't make the foolish mistake of distributing an exponent. Exponents do not distribute. You got to remember that. Okay, this means this quantity times itself. So I want to write that out. So what I started with right here, this right here, this whole thing, that's my factored form. What I'm doing is I'm going to get it to standard. So for today, we don't have the mathematical background to start with standard form and get to factored form. We aren't there yet, but we are going to get there. So I'm going to multiply. The biggest mistake I see when multiplying these is either distributing that exponent, which we've just dealt with that, right? The other mistake is dropping parentheses. So when I multiply this out, I need to remember, and most students get this part right. We multiply this, so we get x squared plus 4x. Then we multiply these two, right? Plus 4x plus 16. And then this is what they do. And now I've made a mistake. Because this means 16 times x minus 3. But that is not what I mean. I mean all of this times x minus 3. Because I'm multiplying. So now I'm going to finish simplifying that just to make the rest of this math easier. Now how we multiply this one is really, it doesn't, you might do from x minus 3 over, or you could do all 3 of these over to the x minus 3. It doesn't matter. I'm going to just go left to right. So I'm going to do this x times both of those. So I get x cubed minus 3x squared. Now what I'm going to do, now you don't have to do this, but what I'm going to do is I'm going to start lining up my like terms so that it's easier to combine. So I'm going to multiply this 8 times both of those. Does anyone not understand why I'm doing what I'm doing as far as how to multiply these? You're quiet, so I'll assume that means you're good. So I get 8x squared minus, careful, 24x. 8 times 3, right? Now, you see how I'm lining up my like terms vertically? I lined up my x squareds. Now I'll do the 16. So the 16 is going to be times the x. So I get plus 16x. And then 16 times the negative 3, so I'll get minus 48. And now I'm going to combine all those. Now you don't have to do what I did. You could just write them all on one line if you would like. So I'm going to get y equals x cubed, nothing like that, plus 5x squared. See why I lined them up? Because now I can quickly add those. And this is my standard form. Do you see what we did? All right. Okay, so now I've given you the answers, like someone has already saw something. I'm going to ask, well, what was the polynomial? Now, we can't 100% say what it is, but we can say what the minimum was, like the actual minimum requirements, because we might have like I have 3 answers here, but maybe there's 2 negative 2's, okay? Maybe there's 3 1's, okay? Well, let's say these are the only 3. We are certain that those are the 3 answers. So we're going to say, well, then x equals negative 2, x equals 0, and x equals 1. And then like we did earlier, we're going to get that over. So x plus 2, nothing to get over, so x, and then x minus 1. These are my factors. So I have x plus 2 times x minus 1. And now we're going to get this in standard form by multiplying. If I just have one thing, I would deal with that one thing first. And I can either multiply that over to the left or over to the right, and it doesn't matter. I'll multiply it over to the left, and I get x squared plus 2x. Does everyone see where I get that? I could have gone to the right. It doesn't matter which way. And now I'm going to finish my multiplying. So that x squared times each of these. So I get x cubed minus x squared plus 2x squared minus 2x. And then I combine those. And when I combine those, I get f of x. My function is x cubed, combine my like terms, plus x squared minus 2x. I combined these. I multiplied this. I got that. Then I multiplied this out. That's where I got this.
Did you distribute both of those?
So when I multiply, like if I have x plus 5 times x minus 1, I do this times both of those, right? And this times both of those, and then I combine. That's what I did here. All right, what about this next one? I have 3 happening how many times? 3 times. So a multiplicity of 3. So that means f of x equals x cubed. Now, is that in standard form? No. If I'm asking, probably not. So I need to actually multiply that out to get it to standard form. So I'm going to multiply each of those things. So I'll do the first group, x squared minus 6x plus 9. Hopefully you get so used to multiplying these you see the patterns and how they come together. If not, that's okay. It just means you'll do a few extra steps. And now I'm going to multiply this into the x minus 3. Don't drop your parentheses. So I get x cubed minus 3x squared minus 6x squared plus 18x plus 9x minus 27. So my f of x after I combine my like terms is x cubed minus 9x squared plus 18x. Well, blah, 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 blah. I have like thing, don't I? So 18 plus 9, 27x minus 27. And that is my polynomial. Okay? Anytime I have an x equals 0, that means x. Okay? So when I write this next one, f of x is going to be x times, now this one would be x equals 5, so x minus 5. Now this 2/3 is going to be tricky. So let's look at that one. That means x equals 2/3. Now I don't want to just subtract the 2/3 over, because that's not how it would be when it factored. I'm going to clear my fraction, so I multiply both sides by 3. And then I subtract the 2. So that's my factor, 3x minus 2. And x squared times x minus 5 times 3x minus 2. And I've multiplied several of these already, so I don't want to spend any more time on you watching me multiply. Okay, hopefully, if you don't get how to multiply, we'll go ahead and do examples later on how to do that. All right, last thing that we'll work on is calculator work after what we're about to do, and factoring. So we're about to factor. So we want to practice that. Now at this stage, most of these are going to look like your quadratics. So let's say I want to factor this. We'll do 2 of them. All right, so for the most part, in these, you're going to have something common that you can take out. In this case, it's in. So we're factoring these. So we take out our x, and then we should be able to factor that. I get x minus 9, x plus 2. Now this is in factored form. See, this is factored form. And this is in standard form. So you need to know your terminology so you know what you're being asked. Sometimes students, what they do is they assume that they're always solving. But in this case, I'm saying write it in factored form. This is the answer. There's nothing to solve. That's it. I'm done. If you were to box this, if you were to say this, you have now gone from a right answer to a wrong answer. Because this is not factored form. This is factored form. Okay? Only actually solve it if you're asked to solve. How about this one? What can I take out? I'm getting it in factored form. Say again? 3x. So that gives me 3x squared plus 2x, then what? Yeah, minus 1. And then I factor this thing in here. Probably plus 1 here and minus 1 right there. That is the factored form. I'm done. That's all she wrote. Okay. That's it for the new section.